sketching the graph of a hyperbola. Sketch the graph of the hyperbola whose equation is 4x squared minus y squared equals 16. The first thing you have to do, class, is write the hyperbola in standard form. That means that you have to get 1 on the right side of the equation. To do that, you simply divide each term of the equation by 16. And then you simplify that. You can reduce here. 4 goes into 4 once, 4 goes into 16 4 times. So that means that this equation would be equivalent to x squared over 4 minus y squared over 16 equals 1. Now this, the author is accepting as standard form. But to be in perfect standard form, we have to have squares for our denominators. So this would really be x squared over, what squared would give us 4? If you said 2, you're right. Okay, minus y squared over, what squared would give us 16? If you said 4, you're right. Equals 1. So this would be exactly in standard form. So we know that when you're dealing with the hyperbola, a is the one under the positive term, a squared. A squared is the one under the positive term. So here a squared is equal to 2. So this means that a is equal to the square root of 2 squared, which would be the square root of 4, which would be 2. This means that b would be equal to square root of 4 squared, which is the square root of 16, which is 4. So you have a and b. Now all we need to do is find c, so that we can graph the foci also. We're just looking around here and see that the author graphed the foci. No, the author did not graph the foci here. But we want to find the foci so that we can have those on there. The formula that we use, as we said before, back on the previous pages, is b squared equals c squared minus a squared. B squared equals c squared minus a squared. So in this case, b we know is 4. So we would have 4 squared, which is 16. C is what we're looking for, so we would have c squared minus a squared. A is 2, so it would be minus 4. And we add 4 to both sides, and that gives us c squared equals 20. We take the square root of both sides. We get c equals the square root of 20. 20 is 4 times 5. So it would be the square root of 4, which is 2, times the square root of 5. For our c squared. Okay, 2 times the square root of 5 is approximately equal to 4.5. So you have to get an estimate for this in order to graph that. So then we're ready to make our graph. So we simply draw a set of axes. And we can see that the positive here is on the x squared term. The positive is on the x squared term. So that means that the transverse axis will be on the x-axis. So that means that from the origin we go over to the right 2, and then from the origin we go to the left 2 for the x radius. So from the origin we go 1, 2 to the right. We go from the origin 1, 2 to the left, and we can draw the sides of the rectangular box. And then for the y radius, we go from the center up 4, and then from the center down 4. So we start at the origin, we go up 1, 2, 3, 4, and we go down 1, 2, 3, 4, and then we can finish off the rectangular box. So there we have the rectangular box. Now all we have to do is draw the diagonals of the rectangular box. Okay, if you have a straight edge, it's best to use that. You can see we're a little off there because that diagonal should go straight through the center, but we're just trying to sketch the graph. If you use graph paper, it would be more exact. So we know that the transverse axis is the x-axis. So we know that the vertex would be located right at that center point there. So we know our graph would look like this. And on the other side, it would look the same way. So you can see how easy it is to graph a hyperbola. Then we can get the equations of the asymptotes. Okay, now if you have the transverse along the x-axis, the equations are y equals b over ax and y equals negative b over ax. So this one here would be y equals b over ax, and b is 4, a is 2, so it's 4 over 2x, and that would be y equals 2x. For this one, this asymptote here, it would be y equals negative b over ax, which would be negative 2x. So those would be the equations of the asymptotes, as you can see there.